Hello my dear students, welcome to this Anti-Ulcer series, and in part 3 today we are seeing proton pump inhibitors. So as I discussed with you in the last lecture that there are 3 to 4 mechanisms and all they are activating the proton pump. Whether it is a gastrin which is released from G cell, it activates the protein kinase further activates the proton pump. The second mechanism which I have seen is that histamine which is released from that of the enterochromaffin cell. It binds with H2 receptor, then that converts ATP to cyclic AMP. Cyclic AMP activates protein kinase, and protein kinase at the end activates proton pump. Proton pump is nothing but the name of enzyme. You should not consider it as a pump. Okay, actually it is enzyme which is pumping the H plus ion. That's what is called as a pump. Okay, otherwise you should not assume that it is a normal type of the pump which we are using in our daily routine life. Okay, actually the function of enzyme is like that, it is pumping the H plus ion. Okay, that's why it is called as a pump. On the other hand, it is a potassium H plus ion enzyme, okay, which do the counter exchange. Okay, so potassium is coming from outside extracellular fluid to the inside the parietal cell, inside the enzyme, inside the parietal cell, and from parietal cell H plus is push out with the help of this enzyme. This enzyme is doing such kind of counter exchange process, and hence it is known as potassium oblique proton pump. Okay. The third mechanism which we have seen is that binding of acetylcholine to the M3 receptor, muscarinic receptor. I can say that it also allows entry of calcium inside the parietal cell. That parietal cell, then calcium calcium activates protein kinase, and protein kinase at the end activates proton pump. So whatever the these four mechanisms are there, okay, whether it is binding of T cell, gastrin, or binding of histamine, or binding of acetylcholine, I can say that at the end it is a proton pump. They all are trying to activate the proton pump. Okay, and if rather than blocking all this four process, okay, if you directly block this proton pump, so whole story will end up, isn't it? So there will not be the counter exchange. There will not be H plus go outside, and from outside K plus will not come inside. And if there is no H plus outside, it will not come in with Cl minus. And hence in today's lecture we are studying proton pump inhibitors. I hope that you understood the basic of the chapter, this segment. Okay, so what kind of drugs are there which could inhibit this proton pump or potassium oblique proton or H plus enzyme? So the name of compounds are omeprazole, pantoprazole, rabeprazole, and lansoprazole. Okay, in your syllabus only two drugs are there, omi and lanso. Okay, remaining two you can do at if you want. So first I'll tell you the basic of this drug, basic pharmacology of this drug. So you can see that imidazole ring, which is common in all the four drugs, isn't it? So imidazole ring is a common. Then sulfonyl methylene is common. And in all the compounds you'll find pyridine, and pyridine. So I hope that this is a common pharmacophore, and almost 90% structure has been done. So what are the pharmacophore feature of this proton pump inhibitor? Imidazole ring. Okay, imidazole is attached with sulfonyl methylene, and sulfonyl methylene is attached to the pyridine, isn't it? Okay, that's so easy to remember the structure. So I'm telling you the first omeprazole. Omi. The brand name of this omeprazole is so Omi. Okay, Omi. Why name Omi would be given? Because it contains methoxy. Methoxy का क्या लिया? Methoxy O, and here you can see that methyl and methoxy and methyl group. So here you can assume methyl of this me. O for alkoxy, methoxy, O me. That's why the name of compound is omeprazole. The next is a pantoprazole. So there is no link because it may be the name of company. There is no any kind of correlation between the name and the structure. But you have to remember that in pantoprazole, methoxy groups are there, and here you can see that this functional group. Okay, then talking about rabiprazole, it don't have any kind of substitution on the imidazole, but here you'll find a longer alkoxy change. Okay, and in lansoprazole again you'll find a OCH2CF3 group. Okay, electron withdrawal group is there. Okay, okay, so I hope that in this way you can remember the structure. Actually, other substitution you have to remember. One more clue I would like to give to you people is that on pyridine ring you'll find electron donor type of the substitution. Okay, like you can see that here methyl is electron donor, methoxy is somewhat extent it comes on the border of electron donor and withdrawing. Okay, so you can see that it is a mild type of the group, not electron donor, not withdrawing. Okay, so I can say that on pyridine you'll find such kind of group which helps nitrogen to easily donate the electron. Okay, in the next slide I'll tell you that what is the role of this nitrogen. Okay, why nitrogen is there in this proton pump. Okay, I'll tell you in the next slide. Now we're talking about the SR. So we'll see the SR of first imidazole ring, SR of sulfonyl-methylene, and SR of then pyridine ring. So benzimidazole, SR of benzimidazole says that this benzimidazole ring should be substituted one. If it is not substituted, then what will happen? So the thyroid enlargement will be the one of the side effect. If this benzimidazole is plain, if it is not having any kind of substitution over here. So this is only one point of benzimidazole SR. Now second point of about this sulfonyl-methylene. So people try to replace the sulfonyl-methylene with a different kinds of group, like they also try to convert SO to SO2CH2. Here you can see the SO2CH2. They also try to convert S. They try to remove both oxygen. Okay, SCH2. But whatever they have attempted, that result in the loss in activity. It means that SOCH2 is essential for the activity. Okay, and SOCH2 is essential for the activity. I can say that, and extending or doing anything with this one, it results in decrease in activity. So I have so far I discussed with the SR of imidazole ring, benzimidazole, SR of sulfonyl-methylene, and now I'm discussing with you about the SR of pyridine. So it is the mode of action of this compound is that these compounds are prodrug. Proton pumps are prodrug. As such, they are not active form. When you took this proton pump inhibitor inside the stomach, okay, such kind of mechanism is going to happen. Actually, this nitrogen donates a lone pair of electron, okay, to this carbon. Okay, here you can see that, and in this way here you can see that this nitrogen is donating electron. Sorry, here you can see that. Okay, this nitrogen is donating electron to this carbon. Okay, so this nitrogen is donating electron to this carbon, and in this way this ring is getting cyclized and new ring is forming over here, and this new ring is responsible for blocking the proton pump inhibitors, proton pump enzyme. Okay, so formation of this ring is essential for binding with proton pump. If this ring is not there, they will not be binding with proton pump, and proton pump will not be getting inhibited, isn't it? And for the formation of this new ring, this nitrogen should donate electron to the carbon, and hence you will find in all the structure you will find that this nitrogen, this pyridine ring is substituted with such kind of group which donates the electron, which are electron donor in nature, because this group should help nitrogen, okay, to donate the electron to the carbon. If you are putting any kind of electron withdrawing group, more strong electron withdrawing group, so that may decrease the I can say that nucleophilicity of nitrogen. And if nitrogen की nucleophilicity अगर कम हो जाएंगी, so this nitrogen will not donate electron easily to carbon, and there will not be formation of this ring. That is ring is called as sulfonamide. This structure is called as sulfonamide. And if sulfonamide is not sulfonamide, it is not sulfona, it is sulfana. Okay, if there is no sulfonamide, the sulfonamide will not bind with proton pump. So this is a mode of action come SAR of this class. And I told you that what is the mode of action of this drug. So this drug, they inhibit the proton pump, this enzyme they are blocking, and if this enzyme is blocked, then whole process will stop and there will not be any kind of HCl secretion. So I hope that you have understood about proton pump inhibitor. Thank you for listening me.